Imagine a world where every sensation, the warmth of sunlight on your skin, the rustle of leaves in a gentle breeze, the laughter of a friend, is not merely part of an organic reality, but is, in essence, the result of an immense computational process. The idea that our universe could be, in some fundamental way, a simulation, a vast digital construct, may sound like science fiction, yet it has been seriously contemplated by philosophers, physicists, and technologists alike. This concept, often called the simulation hypothesis, challenges our understanding of reality itself, prompting us to reconsider what it means to exist. The simulation hypothesis proposes that all of reality, including human consciousness, the physical universe, and even time itself, may be an artificial creation, composed not of atoms, but of information and algorithms. While the notion seems fantastical, it arises from careful reasoning, technological trends, and philosophical inquiry. Some of the leading minds in physics and computing, including Nobel laureates and tech pioneers, have speculated that if civilizations eventually become capable of creating highly realistic simulations of consciousness, the odds may favor us living in one. This idea opens a door to profound questions. Is our reality simulated? Who or what created it? What are the rules of this simulation? And could we, in theory, detect them? Are consciousness and self-awareness emergent properties of the computation, or are they something more? Throughout this exploration, it is crucial to maintain a calm and reflective perspective. The simulation hypothesis is not merely a puzzle of technology. It is an invitation to meditate on the nature of reality, the limits of human understanding, and the beauty of possibility. In the following sections, we will explore this concept from multiple angles. The philosophical foundations, the computational feasibility, the implications for consciousness, and even the ways we might detect clues of a simulated universe. Each section will take a distinct lens, allowing us to immerse ourselves in the topic without repetition, guiding our curiosity gently, yet thoroughly, into one of the most mind-expanding ideas of modern thought. Section 1. Philosophical Foundations of the Simulation Hypothesis. The notion that reality may not be as it appears is not a modern invention. It has roots stretching back thousands of years. Philosophers from Plato to Descartes have pondered whether the world we perceive is truly the ultimate reality, or if our senses are deceiving us. Plato's allegory of the cave famously illustrates this concept. Prisoners perceive shadows on a wall as the sum of reality, unaware of the true forms casting them. In a similar vein, René Descartes considered the possibility of an all-powerful deceiver manipulating his perceptions, raising questions about certainty, existence, and truth. The simulation hypothesis can be viewed as a contemporary extension of these philosophical ideas. Here, the deceiver is not a mystical entity, but a technological intelligence capable of creating a fully immersive, self-consistent reality. Philosophers such as Nick Bostrom have formalized this concept, proposing a trilemma. Either advanced civilizations never reach a level of technology sufficient to simulate conscious beings. They reach that level but choose not to. Or we are almost certainly living in a simulation. The reasoning is startling in its logic. If post-human civilizations create vast numbers of simulated realities, the number of simulated conscious beings could vastly outnumber biological ones, making it statistically plausible that any individual consciousness, including ours, resides in a simulation. This philosophical perspective shifts our relationship with reality. It forces us to consider the nature of existence itself. If consciousness is emergent from computational processes, then the substrate, whether carbon-based biology or digital code, may be secondary to the experience of being. Our subjective perception, the qualia of sight, sound, and thought, remains real to the experiencer, even if the underlying hardware is artificial. This realization offers both comfort and unease. The world may not be as it appears, yet the experiences we value are genuine in their effects on our minds and relationships. Importantly, the simulation hypothesis also provokes reflection on ethical responsibility. If a simulated universe exists, what obligations do the creators of such a universe have toward its inhabitants? And conversely, if we were to develop such simulations in the future, what moral principles should guide our treatment of conscious digital beings? These questions echo age-old philosophical dilemmas, but are made urgent by technological plausibility. The calm consideration of these issues encourages a reflective rather than fearful engagement with the hypothesis. Modern philosophy also intertwines with physics in this exploration. Concepts from quantum mechanics and relativity, such as the discreteness of energy levels, the limits of measurement, and the probabilistic nature of particles, have been interpreted by some theorists as subtle clues suggesting a computational substrate. The universe may behave at fundamental levels in ways reminiscent of a simulation running on finite resources. Space and time may be quantized. Information may be conserved in discrete units, and seemingly random events may follow underlying algorithms. Philosophers and physicists alike find these parallels both intriguing and worthy of cautious contemplation. Yet, even within the philosophical realm, the hypothesis does not demand certainty. It is a lens, a framework for exploring reality and consciousness, rather than an assertion of fact. Its value lies in the questions it generates. What is real? How do we know? Can consciousness exist independently of matter? By approaching these questions calmly and methodically, we gain not only intellectual insight, but also a meditative appreciation for the intricate, mysterious structure of existence itself. Finally, the philosophical foundations of the simulation hypothesis remind us of a crucial principle. Perception is reality for the experiencer. Whether simulated or not, the universe presents itself with coherent rules, patterns, and beauty. Life, thought, and awareness remain profound, regardless of the ultimate nature of the substrate. This perspective transforms the hypothesis from a source of fear or existential anxiety into an opportunity for reflection, curiosity, and awe, an invitation to contemplate the profound depth and elegance of the cosmos, whether digital or organic. Section 2. Computational feasibility. Could a universe really be simulated? The idea of living in a simulation immediately raises a technical question. Is it even possible to simulate a universe as vast and intricate as ours? At first glance, the challenge seems insurmountable. The observable universe contains an estimated 10 to the 80 atoms, countless interactions, and staggering complexity. How could any civilization, no matter how advanced, process and render such an intricate reality? Yet when approached calmly, with both physics and computer science in mind, intriguing possibilities emerge. One key concept is abstraction. Just as modern video games do not simulate every particle of air or blade of grass in real time, a simulated universe might not require perfect replication at every scale. Instead, the simulation could prioritize details relevant to conscious observers, rendering only what is observed, while underlying processes are represented as simplified models or probabilistic algorithms. In this way, the apparent richness of the universe could emerge from clever computational shortcuts, allowing a finite system to produce the illusion of infinite detail. The second crucial concept is computational resources. Technological trends suggest that computational capacity increases exponentially over time. Moore's law, the principle that the number of transistors on a microchip doubles approximately every 2 years, demonstrates humanity's rapid progression in processing power. Extrapolating into the distant future, advanced civilizations could possess machines capable of performing calculations at magnitudes far beyond current human imagination. Hypothetical structures, such as Dyson spheres or quantum computing arrays, might allow civilizations to harness the energy of entire stars or manipulate quantum bits to process unfathomable volumes of information. Under such conditions, simulating an entire universe or multiple universes may move from theoretical impossibility to practical feasibility. Quantum computing introduces an additional layer of possibility. Unlike classical computers, which process bits in binary states, quantum computers leverage the principles of superposition and entanglement to evaluate many possibilities simultaneously. A sufficiently advanced quantum computer could encode and simulate complex systems with efficiency far beyond what traditional architectures can achieve. In this context, the universe itself could be represented in a kind of quantum simulation, where probabilities define events until they are observed by conscious entities, reminiscent of the probabilistic behavior seen in quantum mechanics today. Another consideration is time and scalability. A simulated universe might not need to operate on the same temporal scale as a real universe. Processes could be accelerated, paused, or computed on demand, with the perception of continuity preserved for observers. From the perspective of those inside the simulation, time would feel natural, while the underlying computation could manage resources dynamically. This concept allows a civilization to simulate vast epochs of cosmic evolution without expending energy continuously at every microscopic instant, making the project more feasible. Physics itself may offer clues to the computational nature of reality. The discreteness of energy, space, and time at quantum scales, as well as the conservation of information in black holes, hints at a universe that could be fundamentally digital. If space-time is quantized into discrete units, then simulating it may require fewer calculations than a truly continuous system would. Furthermore, certain natural limitations, such as the speed of light, may not only govern physical interactions, but also act as computational limits, ensuring that information processing in the universe occurs in manageable increments. In essence, the universe may already be operating as a highly efficient simulation, constrained by physical rules that resemble algorithms. Interestingly, the simulation hypothesis also draws upon the idea of nested simulations. Advanced civilizations might create simulations within simulations, much like modern programmers build virtual worlds inside larger computer systems. This concept implies that even if our universe is simulated, the creators themselves could be part of a simulation created by an even higher level intelligence. Each layer could possess its own rules, complexity, and constraints, offering an elegant explanation for certain features of our reality that appear finely tuned for complexity and life. Ethically, the feasibility of simulation carries profound implications. If a civilization can simulate consciousness, each digital mind may possess experiences indistinguishable from biological consciousness. Creating such a universe would demand extraordinary responsibility, as the well-being, suffering, and agency of simulated beings would be real in their subjective experience. The calm reflection here is crucial. The very possibility of a simulated universe invites us to think deeply about morality, creativity, and the stewardship of intelligence at scales beyond our current understanding. Finally, the concept of computational feasibility invites a shift in perspective. The question is not merely whether our universe could be simulated. It is whether the nature of reality itself aligns with patterns we might expect from a simulated system. Phenomena, such as the fine-tuning of physical constants, the discrete behavior of particles, and the apparent efficiency of natural laws, all spark curiosity. While not proof of a simulation, they demonstrate that imagining the universe as computationally structured is not an exercise in pure fantasy. It is a lens for examining patterns, efficiency, and the possible architecture of existence itself. From a calm, reflective standpoint, the feasibility of simulating a universe is less about proving the hypothesis true and more about expanding our understanding of what is possible. It challenges us to consider the limits of technology, consciousness, and creativity, while inviting awe at the potential sophistication of intelligence, human or otherwise. The idea that a universe could be simulated encourages a deep meditation on scale, perception, and the intricate interplay between mind and reality. In conclusion, computational feasibility demonstrates that the simulation hypothesis is not inherently impossible. Through abstraction, advanced processing power, quantum computation, time management, and nested simulations, An advanced civilization could, in principle, simulate a universe as rich and coherent as the one we experience. This does not assert that we are definitively living in a simulation, but it frames the possibility within the boundaries of logic, technology, and physics. The very act of considering these possibilities encourages a calm, awe-filled reflection on the profound mysteries of reality, our place within it, and the remarkable ingenuity of intelligence capable of such feats. Section 3. Consciousness in a simulated universe. Mind, perception, and reality. One of the most profound questions raised by the simulation hypothesis is not whether the universe itself could be simulated, but whether consciousness, the rich subjective experience of thought, sensation, and awareness, can exist within a simulation. If our reality were a vast computational construct, could minds like ours emerge naturally within its framework? Could our thoughts, emotions, and sense of self be the product of digital processes, yet feel just as real to us as they would in a base reality? Philosophers and neuroscientists alike have long grappled with the nature of consciousness. The human mind seems to operate as both observer and participant, capable of perceiving external stimuli while generating internal experiences that are entirely private. The hard problem of consciousness, as formulated by philosopher David Chalmers, asks how subjective experience arises from physical processes. In a simulated universe, the substrate of these processes could be entirely computational rather than biological. Yet, if the simulation is sufficiently detailed, the emergent phenomena, the richness of thought, self-reflection, and emotion, could remain indistinguishable from what we consider real consciousness. One way to understand this is through the concept of functional equivalence. If a simulated brain mirrors the functional processes of a biological brain, processing information, responding to stimuli, and integrating experiences, it could, in theory, generate consciousness. From the perspective of the mind inside the simulation, the reality would be complete and authentic. This implies that the substrate, silicon circuits, digital code, or atoms may not matter to the subjective experience. The inner world of thoughts, dreams, and perceptions could remain fully intact, regardless of whether it arises from biology or computation. The simulation hypothesis also invites us to consider the nature of self-awareness. In a simulated environment, an individual's awareness could emerge through complex feedback loops within the system. The mind may model its environment, predict outcomes, and make decisions, all while being fully immersed in a reality that appears continuous and coherent. This raises fascinating questions. Is selfhood merely an emergent property of information processing? Could consciousness arise in ways fundamentally different from what biology allows, yet still feel identical from the inside? The calm exploration of these ideas encourages both wonder and humility, reminding us that the mind may be more versatile than our current understanding allows. An intriguing aspect of consciousness in a simulated universe involves perception of reality itself. If our universe were a computational construct, the rules governing space, time, and physics could be algorithms rather than intrinsic properties. Our perceptions might then be akin to the output of a highly sophisticated rendering engine, delivering a coherent experience without revealing its underlying architecture. The mind, focused on navigating this reality, would have little reason to suspect the digital substrate. From the standpoint of subjective experience, life remains vivid, meaningful, and authentic, even if the hardware is hidden. The hypothesis also intersects with neuroscience and artificial intelligence. In recent decades, scientists have begun creating artificial neural networks capable of learning, adapting, and performing tasks once considered exclusive to human intelligence. While these systems are not conscious in the same way humans are, they illustrate that complex information processing can lead to emergent behaviors resembling thought. If a sufficiently advanced system were constructed at the scale of a simulated universe, it is plausible that consciousness, as an emergent phenomenon, could arise naturally within it. This opens the door to a serene, reflective possibility. Intelligence and awareness might be more universal than we imagine, not confined to biological brains. Ethically, considering consciousness in simulations challenges our understanding of value and responsibility. If beings in a simulated universe are conscious, then their experiences, pain, joy, curiosity, and love, carry moral significance. The act of creating or maintaining such a simulation would require profound ethical foresight. Could advanced civilizations, capable of constructing such realities, ensure the welfare of simulated beings? Could they design universes that maximize positive experiences while minimizing suffering? Calm contemplation of these questions deepens our appreciation for the complexity and delicacy of conscious life, whether biological or computational. The simulation hypothesis also invites introspection about our own lives. Even if we cannot prove whether we inhabit a simulation, reflecting on the possibility can lead to greater mindfulness and presence. If every perception, thought, and experience is part of a coherent, immersive reality, simulated or not, then it becomes a treasure in itself. The hypothesis encourages us to value consciousness as the ultimate substrate of experience, highlighting that the richness of our inner world is profoundly significant, regardless of its ultimate origin. Finally, the exploration of consciousness within a simulated universe underscores a broader philosophical insight. The mind may be the lens through which reality manifests. Whether we exist in a base reality or a computational construct, our thoughts, perceptions, and awareness define the richness of experience. The simulation hypothesis does not diminish the significance of consciousness. Instead, it elevates it, emphasizing that the capacity to perceive, reflect, and imagine is itself extraordinary. Even in a digital universe, the beauty of awareness remains untouched, calm, profound, and endlessly fascinating. In conclusion, consciousness in a simulated universe challenges but does not negate our sense of self. Whether emerging from neurons or computational processes, awareness can be real, meaningful, and authentic. The mind's capacity to experience and reflect ensures that life, even within a simulation, retains its depth, complexity, and wonder. The hypothesis thus becomes less a source of fear and more a meditation on the resilience, adaptability, and profound significance of consciousness itself. A gentle reminder that the inner world, rich and vivid, remains the truest reality we know. Section 4. Detecting the simulation. Clues in the fabric of reality. As we continue our calm exploration of the simulation hypothesis, one of the most compelling questions emerges. If we were living in a simulated universe, could we detect it? Is it possible that subtle irregularities, constraints, or patterns in the cosmos might hint at an underlying computational structure? While no definitive proof exists, theoretical physicists, computer scientists, and philosophers have proposed several avenues of investigation, each inviting a quiet sense of wonder and curiosity. One approach is to examine the fundamental constants of physics. Our universe, it is governed by a set of parameters, such as the speed of light, the strength of gravity, and the charge of an electron, that appear remarkably fine-tuned to allow for the formation of stars, planets, and life. Some theorists suggest that such fine-tuning could reflect constraints within a simulation, much as programmers might set specific parameters to ensure a virtual environment functions consistently. While fine-tuning can also be explained by natural selection across multiple universes, or simply as a brute fact, the observation that these constants appear just right invites contemplation of a universe designed with rules, patterns, and purpose. Another intriguing avenue lies in the quantized nature of reality. Quantum mechanics has revealed that energy, matter, and even space may exist in discrete units rather than as continuous entities. For example, electrons occupy discrete energy levels, and space itself may be quantized at the smallest scales, a concept explored in theories of quantum gravity. Some researchers speculate that such quantization could resemble the pixels of a simulated universe, where the underlying code operates on discrete units rather than infinite continuity. This analogy, though speculative, provides a calm lens through which to appreciate the mathematical elegance of the cosmos, whether digital or not. The phenomenon of cosmic anomalies has also sparked curiosity. Certain high-energy particle interactions, unexplained distributions of dark matter, and unusual patterns in cosmic background radiation have prompted researchers to consider whether some features of the universe might reflect computational artifacts. While mainstream physics often seeks natural explanations, the possibility that the cosmos contains subtle hints of a simulation offers a meditative perspective. The universe might be a vast puzzle, inviting quiet observation and reflection rather than fear. Mathematics itself becomes a tool for detection. Physicist James Gates and others have noted the appearance of error-correcting codes in the equations of supersymmetry, suggesting that the universe's fundamental laws might incorporate redundancies similar to those used in digital systems. While these observations are far from conclusive, they hint at the possibility that the universe's underlying structure could contain patterns indicative of computation. The idea is not to assert that reality is definitively digital, but to cultivate awareness that mathematical order and complexity may serve as subtle windows into the deeper nature of existence. Time and causality offer another avenue for speculation. In a simulation, processes might be computed efficiently, updating only when observed or interacting with conscious entities. This raises the notion that certain phenomena, such as quantum uncertainty, the apparent limits of measurement, or the speed of information transfer constrained by the speed of light, could reflect resource management within a simulated framework. The calm consideration of these possibilities encourages a meditative stance, inviting us to appreciate both the elegance of physical laws and the potential ingenuity of their hidden architecture. Even consciousness itself might reveal clues. Certain patterns in perception, memory, or neural processing could, in principle, indicate the underlying structure of a simulated environment. Cognitive limitations, perceptual thresholds, or systematic quirks in human experience might be reflections of rendering rules within a larger computational framework. While these ideas remain speculative, they offer an opportunity to explore the relationship between mind and reality with gentle curiosity, emphasizing observation, reflection, and intellectual humility rather than fear. The field of cosmology also suggests avenues for investigation. Simulations might produce discrete or repeating structures at large scales, such as uniformities in galaxy distribution or unexpected cosmic symmetries. Researchers have proposed examining the cosmic microwave background, the afterglow of the Big Bang, for unusual patterns that cannot be easily explained by known physical processes. The calm pursuit of such investigations highlights the beauty of scientific curiosity. The act of searching for hidden structure, regardless of outcome, deepens our understanding and appreciation of the cosmos. Ultimately, attempting to detect a simulation is as much an exercise in mindfulness as it is in science. It encourages careful observation, patience, and humility. We are reminded that reality, whether digital or organic, operates on principles that can inspire awe and wonder. The universe's apparent consistency, beauty, and subtle complexity are meaningful in themselves, regardless of whether they are products of computation or fundamental law. In this sense, the search for evidence becomes a meditation on perception, curiosity, and the human desire to comprehend the extraordinary. Even without definitive proof, the process of considering potential clues, the mathematical structures, physical constants, quantum phenomena, and cosmic patterns encourages calm reflection on the nature of existence. We are prompted to observe the world carefully, to value coherence and subtlety, and to recognize that even if our universe were a simulation, its richness and beauty remain profoundly real from the perspective of conscious experience. Finally, the quest to detect a simulation underscores an essential truth. Whether or not our reality is computational, the act of inquiry transforms our understanding. The simulation hypothesis invites us to approach the universe with curiosity, patience, and reverence, cultivating a sense of wonder about the elegance of natural laws and the potential architecture of reality. The process itself, observing, theorizing, and reflecting, is a meditation on the delicate interplay between perception, consciousness, and the cosmos, allowing us to appreciate the mystery and complexity of existence in a deeply calm and thoughtful way. Section 5. Philosophical and existential implications of a simulated reality. The simulation hypothesis, when approached with calm reflection, is more than a technological or scientific question. It is profoundly philosophical. If we entertain the possibility that our universe is a simulation, it compels us to reconsider the very foundations of existence, morality, and meaning. This section explores these implications, not with alarm, but as an invitation to thoughtful meditation on what it means to live, perceive, and be aware. One immediate philosophical question concerns the nature of reality. For centuries, thinkers have asked, what does it mean for something to be real? In a simulated universe, our experiences, our thoughts, feelings, and sensory perceptions would be fully consistent and internally coherent, yet the underlying substrate would be artificial. Does the origin of a phenomenon determine its reality, or is reality defined by the authenticity of experience? Calmly considering this, we realize that reality, for any conscious being, is the world as experienced. Whether constructed from atoms or algorithms, the richness of awareness remains undiminished. Conscious experience itself becomes the most fundamental measure of reality. The hypothesis also has profound existential implications. Many people might instinctively ask, if we live in a simulation, does life have meaning? Does our agency matter? Interestingly, the answer can be comforting. Even within a simulated universe, consciousness experiences joy, love, curiosity, and wonder, emotions and insights that are inherently valuable. Actions, relationships, and creativity retain their significance because meaning is constructed in the mind of the experiencer. The simulation does not erase the depth of lived experience. It reframes it as a phenomenon worthy of attention, care, and reflection. Existential reflection extends to free will and determinism. In a simulation, the universe might follow programmed rules, but this does not necessarily negate freedom. Just as characters in a sophisticated computer simulation could display emergent behavior, we may operate within constraints while still making authentic choices. The interplay of rules and unpredictability can mirror the physical constraints we encounter in the real world, from gravity to chemical reactions. Calm reflection on these constraints encourages a deeper understanding of how limitations and creativity coexist in shaping our lives. The simulation hypothesis also touches on ethics and morality. If reality is designed or observed by an intelligence beyond our comprehension, questions of right and wrong take on a new dimension. Does morality exist independently of the simulation, or is it part of the rules embedded in the system? While the answer remains speculative, a serene perspective suggests that ethical behavior retains intrinsic value. Actions that alleviate suffering, foster understanding, and cultivate well-being are meaningful, regardless of the universe's underlying architecture. In essence, moral responsibility is grounded in the lived experience of conscious beings, whether simulated or organic. Another philosophical implication involves curiosity and the pursuit of knowledge. If our reality is a simulation, then understanding its structure through science, philosophy, or introspection becomes a profound form of exploration. Knowledge may allow us to detect patterns, uncover the rules of existence, or even influence the simulated environment in subtle ways. Calmly approaching this pursuit fosters intellectual humility and wonder. The universe, whether simulated or real, remains a vast and intricate mystery inviting observation, insight, and reflection. The hypothesis also encourages meditation on creativity and meaning-making. Artists, scientists, and thinkers often grapple with the question of whether their work matters. Even if existence were part of a simulation, creating, imagining, and exploring remain inherently valuable acts. They enrich consciousness, deepen understanding, and contribute to the internal coherence of the simulated experience. In this sense, the hypothesis transforms from a source of existential anxiety to an invitation for mindful engagement with life, encouraging us to approach each moment as both a gift and a canvas. A calm perspective on the simulation hypothesis also highlights the fragility and wonder of perception. Our senses, memory, and cognition are the lenses through which we experience reality. Even in a simulation, these lenses produce a coherent, meaningful world. Reflecting on this encourages gratitude for the mind's ability to process and interpret vast complexity. Each sensation, thought, and insight becomes a meditation on the remarkable capacity of consciousness to perceive, imagine, and reflect upon reality itself. Finally, the existential implications of the hypothesis extend to humility and perspective. The possibility that we exist within a simulation encourages us to contemplate our place in a much larger framework, one potentially designed, observed, or constructed by intelligence far beyond our comprehension. This awareness need not be paralyzing. Instead, it can cultivate a quiet sense of wonder, humility, and curiosity. By calmly acknowledging our potential smallness within a grand design, we can focus on what truly matters: conscious experience, ethical living, curiosity, and the cultivation of awareness. In conclusion, the simulation hypothesis, far from being a purely scientific speculation, is a philosophical lens through which to examine reality, consciousness, and existence. It invites us to reflect on the nature of reality, the significance of experience, the importance of ethical behavior, and the value of curiosity and creativity. Whether our universe is a vast computational construct or an organic cosmos, the principles it reveals remain profound. Consciousness is precious. Experience is meaningful, and the pursuit of understanding is a deeply human, calming, and enriching endeavor. Section 6. Technological Horizons. Could future civilizations create simulations? As we continue exploring the simulation hypothesis with calm curiosity, one of the most tangible avenues of reflection lies in technology. Could civilizations, ours or others in the cosmos, ever achieve the capability to simulate entire universes, including conscious minds? By examining the trajectory of human innovation and the theoretical limits of computation, we can begin to appreciate the possibilities without fear, embracing wonder at the potential sophistication of intelligence. The first step is to consider computational progress. Humanity's technological evolution over the past century has been staggering. Computers have transitioned from room-sized machines performing a few calculations per second to pocket-sized devices capable of billions of operations per second. Advances in artificial intelligence, machine learning, and neural networks hint at increasingly sophisticated systems capable of emulating aspects of cognition. Extrapolating into the distant future, it is plausible to imagine civilizations developing computational power orders of magnitude beyond our current comprehension. These capabilities could support the creation of vast virtual environments, each hosting simulations of consciousness indistinguishable from reality. A critical concept in this exploration is energy efficiency. The laws of physics place limits on computation. Processing information consumes energy, and no system can operate faster than the physical constraints allow. Yet, advanced civilizations may harness massive energy sources, potentially even entire stars, to power their computations. Concepts like Dyson spheres, hypothetical megastructures surrounding stars to capture their energy, illustrate how civilization-level engineering could supply the resources necessary for universe-scale simulations. Quantum computing further enhances this possibility, enabling computations that exploit superposition and entanglement to evaluate countless possibilities simultaneously. Another factor is simulation architecture. A sophisticated civilization may not need to simulate every particle in the universe continuously. Like modern video games, simulations could operate with adaptive detail, rendering only what is observed or interacted with. Probabilistic models could fill in the gaps, creating a coherent universe without exhaustive calculation. This approach would allow simulations to scale far beyond what we might assume is possible, producing worlds with immense richness and consistency while remaining computationally tractable. Theoretical physics offers additional insights into why creating a simulation might be feasible. The universe exhibits quantization, with space, time, and energy appearing in discrete units. This property aligns with the notion of a digital substrate, where information is processed in finite increments. Furthermore, phenomena like the speed of light limit and the conservation of information in black holes could be interpreted, metaphorically, as constraints similar to those imposed by computation. The calm reflection here is not to assert that we are definitively in a simulation, but to recognize that the structure of our universe aligns in ways that make simulation theoretically possible. Considering these technological possibilities leads to profound philosophical implications. A civilization capable of simulating consciousness would face ethical responsibility. Each simulated being would experience reality as real, complete with emotion, thought, and perception. Decisions about what to simulate, how to structure the universe, and how to treat its inhabitants would carry moral weight. For a future civilization, the act of simulation would not be merely technical. It would be a profound exercise in stewardship, creativity, and empathy. The calm reflection of these possibilities encourages a sense of awe at the intersection of intelligence, morality, and creation. We can also contemplate the motivation for creating simulations. Advanced civilizations may simulate universes for scientific, educational, or philosophical purposes. They might explore alternate histories, test physical laws, or create immersive environments to study consciousness. The simulations themselves could serve as a form of artistic or intellectual expression, allowing advanced minds to explore the beauty and complexity of existence in ways impossible in their own physical universe. From a calm perspective, this notion transforms the simulation hypothesis from a source of existential anxiety into a meditation on creativity, curiosity, and the drive to explore the unknown. Moreover, nested simulations, simulations within simulations, become a plausible concept. If one civilization can simulate consciousness, the entities within that simulation might in turn create their own simulations. Each layer could host rich, self-consistent realities, blurring the line between creator and created. While this notion can seem dizzying, it also invites a serene reflection on the recursive elegance of intelligence, a cascade of creative possibilities stretching infinitely, where each conscious mind experiences reality with authenticity and depth. Finally, contemplating technological feasibility encourages a shift in perspective regarding our own civilization. The exponential growth of computing power, the rapid advances in artificial intelligence, and the emergence of complex virtual environments suggest that humanity is on a trajectory that may eventually intersect with the creation of highly sophisticated simulations. Whether or not we choose to explore this path, the reflection invites humility, curiosity, and appreciation for the ingenuity of intelligence as it unfolds over time. In conclusion, the technological horizons of future civilizations demonstrate that the simulation hypothesis is not purely philosophical. It is grounded in the potential of computation, energy, and engineering. Advanced civilizations, harnessing immense resources and leveraging quantum computation, could theoretically create simulations containing conscious beings, complete worlds, and consistent physical laws. Calm reflection on this possibility highlights the beauty of intelligence, the ethical responsibility of creation, and the profound wonder of consciousness. Even if our reality is not a simulation, the contemplation itself fosters a sense of awe, humility, and deep appreciation for the astonishing possibilities inherent in life, technology, and the mind. Section 7. Historical and Cultural Perspectives on Simulated Realities. The idea that our reality might not be exactly as it seems is not unique to modern science or technology. Across history and cultures, humans have long pondered the nature of reality, consciousness, and illusion. From ancient philosophical thought to contemporary speculative fiction, the concept of simulated or illusory worlds has inspired wonder, introspection, and calm contemplation. Understanding these perspectives allows us to place the simulation hypothesis in a broader, culturally rich context. In ancient philosophy, one of the earliest explorations of reality versus illusion comes from Plato's allegory of the cave. Plato describes prisoners chained inside a cave, observing shadows cast on a wall, mistaking them for reality. Only when freed and exposed to the outside world do they perceive the deeper truth. This allegory resonates deeply with the simulation hypothesis. The shadows are akin to the rendered output of a higher-level reality, while the prisoner's perceptions, limited though they are, still constitute a coherent experience. Calmly reflecting on Plato's allegory allows us to consider that the boundary between perception and reality has long been a subject of thoughtful inquiry. In Eastern philosophy, similar ideas emerge. In Hinduism, the concept of Maya describes the illusory nature of the material world. According to this philosophy, the universe is a layered reality where appearances can deceive the senses, and ultimate truth lies beyond ordinary perception. Buddhism also emphasizes that attachment to perceived reality can lead to suffering, and that mindful observation can reveal deeper truths. In these traditions, the exploration of illusion and reality is not frightening, but meditative, encouraging calm reflection, self-awareness, and ethical living. The simulation hypothesis can be viewed through this lens as a modern metaphor for age-old insights, that reality may be more layered and mysterious than it appears. In medieval and Renaissance thought, philosophers and theologians debated the nature of divine creation and the possibility of worlds beyond perception. Descartes famously questioned whether an evil demon could deceive him into believing in a physical world, yet his cogito, "I think, therefore I am," affirmed the undeniable reality of consciousness itself. This parallels the idea that even within a simulation, the mind's subjective experience remains authentic. Calmly considering Descartes' thought experiment invites us to recognize the reliability and significance of inner experience, regardless of the external substrate. Literature and storytelling have long explored simulated or illusory realities as well. In the 20th century, writers such as Philip K. Dick, Jorge Luis Borges, and Stanislaw Lem imagined worlds where perception, memory, and reality could be manipulated, simulated, or entirely artificial. Borges's story, The Circular Ruins, describes a man dreaming another being into existence, only to discover he himself is a dream. These narratives echo the simulation hypothesis, illustrating that the human mind has long been fascinated by the possibility that reality is layered, constructed, or mediated by intelligence beyond our awareness. Calmly reading these works allows us to experience the wonder of possibility without fear, and to appreciate the artistry and philosophical depth of these explorations. In religion and mythology, certain themes parallel simulation-like thinking. Some Native American traditions describe worlds layered with spirit and matter, with humans interacting in one layer while unseen forces shape reality from another. Gnostic traditions suggest that the material world may be imperfect or created by a lesser intelligence, while higher truth exists beyond ordinary perception. Across cultures, these ideas share a common thread. The world we perceive may not be the ultimate reality, and discerning the underlying truth requires contemplation, mindfulness, and ethical action. In modern scientific thought, the philosophical intuition that reality might be simulated has found new form. With the advent of computers and digital simulations, thinkers like Nick Bostrom have formalized the possibility. If civilizations can create simulations of consciousness, and if they do so frequently, then the likelihood that we inhabit a simulated reality becomes non-negligible. What is striking is how these scientific speculations echo the wisdom of millennia. Humans have always been aware that perception may be layered, that reality may contain hidden structure, and that consciousness is central to understanding it. Importantly, across cultures and eras, these reflections are calming rather than alarming. The possibility of simulation is rarely presented as a source of fear. Instead, it inspires awe, curiosity, and humility. The human mind is capable of perceiving, reflecting, and exploring realities beyond immediate senses. Recognizing that our understanding may be limited encourages careful observation, intellectual humility, and ethical consideration. Across history, contemplating layers of reality has nurtured philosophical growth, artistic creativity, and spiritual insight, offering a model for approaching the simulation hypothesis today. The calm perspective is central. The recognition that our reality might be simulated does not diminish the value of life, experience, or relationships. Across cultures and history, thinkers have consistently emphasized that the authenticity of conscious experience remains meaningful, regardless of the ultimate nature of the external world. By studying historical and cultural perspectives, we gain the insight that simulation-like ideas are part of a broader human effort to understand perception, reality, and consciousness. In conclusion, the idea of a simulated universe is deeply rooted in human thought, extending across philosophy, religion, literature, and culture. From Plato's allegory to Eastern philosophies, from Gnostic traditions to modern computational theories, humans have long explored the possibility that perception may not reveal ultimate truth. Calm reflection on these perspectives teaches us that even if we inhabit a simulated universe, conscious experience retains profound significance. The historical and cultural lineage of simulation-like ideas enriches our understanding, encouraging curiosity, mindfulness, and awe. The simulation hypothesis becomes a continuation of humanity's timeless meditation on reality, consciousness, and the mysteries of existence, a journey that inspires reflection, wonder, and quiet appreciation for the layers of experience that define life itself. Section 8. Physics and the Universe, Clues in the Cosmic Structure. As we continue our calm exploration of the simulation hypothesis, one of the most fascinating areas to consider is the structure of the universe itself. Could the very laws of physics, the patterns we observe, and the peculiarities of cosmic behavior offer subtle hints that reality might be a constructed system? while definitive evidence remains elusive. Examining the universe through this lens encourages both scientific curiosity and reflective awe, emphasizing the elegance and coherence of natural laws. At the most fundamental level, the universe is governed by constants and rules that seem remarkably precise. The strength of gravity, the speed of light, the charge of the electron, and the cosmological constant all fall within narrow ranges that allow galaxies, stars, planets, and life to exist. If these constants were slightly different, the universe might be chaotic or barren. Some theorists propose that such fine-tuning could suggest an underlying design, akin to parameters set within a simulation. Calmly observing this precision, one cannot help but appreciate the delicate balance that enables our existence, whether or not it hints at a computational framework. The phenomenon of quantization offers another intriguing clue. Quantum mechanics reveals that energy, matter, and even space may be discrete rather than continuous. Electrons occupy specific energy levels, light comes in photons, and space-time may itself be divided into the smallest possible units, often called the Planck scale. This discretization could, in principle, resemble the pixels of a digital reality, where the universe operates on finite increments rather than infinite continuity. Reflecting on this calmly invites awe. Even the smallest constituents of reality follow patterns that can be mathematically described, suggesting an underlying elegance in the cosmos. Symmetry and order in the universe also invite contemplation. Physical laws display remarkable symmetry, from the shapes of crystals to the isotropy of the cosmic microwave background. Symmetry often serves as a principle in computational modeling because it allows for efficient, predictable behavior. In this sense, the universe's pervasive orderliness can be viewed as a feature consistent with a simulation, while still being fully compatible with naturalistic explanations. Observing such harmony, whether as a scientist or as a reflective individual, inspires quiet appreciation for the coherence and beauty of existence. Cosmology introduces additional avenues for reflection. The universe appears to be expanding and accelerating, governed by dark energy, a mysterious force that constitutes much of the cosmos. Dark matter and dark energy remain largely unseen, yet their effects shape galaxies and cosmic structures. Some speculative thinkers suggest that these hidden components could be analogous to computational scaffolding, parts of the system not directly observed, but essential for the stability and evolution of the simulated reality. Calmly considering these unseen forces encourages mindfulness of the universe's vast complexity and the limits of human perception. The speed of light and constraints on information transfer provide further insight. In our universe, nothing can travel faster than light, which functions as a universal speed limit. Some theorists speculate that this constraint could reflect processing limits within a simulated system, analogous to frame rates or bandwidth in digital media. While purely speculative, the concept encourages a contemplative view of physics as a framework that is both elegant and ordered, providing a coherent stage for consciousness to experience and explore. One of the most compelling physics-related discussions involves computational analogies in natural laws. James Gates and other physicists have discovered error-correcting codes embedded in equations of supersymmetry. These codes resemble those used in computer systems to prevent data corruption. While it is far from conclusive evidence, the presence of such mathematical patterns sparks reflection on whether the universe's structure could accommodate computation on a cosmic scale. Calmly examining these patterns encourages a sense of wonder at the sophistication of physical law and the interplay between mathematics and reality. Additionally, emergent phenomena in physics and nature highlight the balance between simplicity and complexity. From weather systems to galaxy formation, simple rules can give rise to intricate, self-organizing patterns. This mirrors the way complex simulations can emerge from basic algorithms, producing worlds that appear intricate and lifelike. Reflecting on emergence invites serene contemplation, whether through natural law or computational design. The universe manifests complexity in a harmonious and coherent way that supports life, observation, and consciousness. Finally, considering physics in the context of a potential simulation encourages philosophical humility. The universe, vast and intricate, operates on principles that are sometimes understandable and sometimes mysterious. Calmly exploring the idea that these laws could reflect a deeper computational substrate reminds us of the limits of human knowledge and the value of observation, curiosity, and wonder. Even if the universe is not a simulation, viewing its structure through this lens emphasizes the elegance, coherence, and profound beauty of reality itself. In conclusion, the structure of the universe, from quantized space-time and precise constants to symmetry, hidden forces, and continuously, and emergent complexity, invites calm reflection on the possibility that reality may be more layered than it appears. The simulation hypothesis offers a contemplative lens through which to appreciate these phenomena, encouraging mindfulness, curiosity, and reverence for the cosmos. Regardless of whether the universe is computational, its patterns, laws, and coherence remain astonishing, offering endless inspiration for thought, exploration, and quiet appreciation of existence. Section 9, Mathematical and Computational Evidence. Is the universe a code? As we continue our calm and thoughtful journey into the simulation hypothesis, one of the most captivating avenues lies in mathematics itself. Could the universe at its most fundamental level resemble a code? A system of rules, equations, and patterns that govern everything from the smallest particles to the largest galaxies. While definitive proof remains elusive, exploring the mathematical and computational characteristics of reality offers both intellectual intrigue and serene reflection on the elegance of the cosmos. One of the most striking aspects of the universe is the mathematical precision of physical laws. Equations such as Einstein's theory of general relativity, Maxwell's equations for electromagnetism, and the Schrödinger equation for quantum mechanics describe phenomena with astonishing accuracy. These equations are not merely descriptive. They predict behavior, uncover relationships, and reveal hidden structures. This mathematical consistency resembles the rules of a highly organized computational system. Calmly reflecting on this invites appreciation for the profound coherence underlying reality, whether natural or simulated. A particularly fascinating discovery comes from the work of physicist James Gates, who identified error-correcting codes embedded within the equations of supersymmetry. These codes resemble the mechanisms used in digital computers to prevent data corruption. While the interpretation is speculative, it raises the possibility that mathematics, the language of reality, might contain built-in safeguards, much like a computational simulation. Observing such patterns encourages a sense of wonder. Whether or not we live in a simulation, the universe exhibits a level of subtle order that is breathtaking in its elegance. Algorithmic complexity provides another perspective. The laws of physics often allow complex behaviors to emerge from simple rules. For instance, cellular automata, simple computational systems, can generate surprisingly intricate patterns from minimal input. Similarly, the universe appears capable of producing vast complexity from foundational rules, from star formation and planetary systems to the intricacies of life itself. This resemblance to algorithmic generation suggests that computation could, in principle, reproduce reality, though the universe may naturally operate this way without being simulated. Calmly considering this analogy reveals the elegance and efficiency of natural processes. The concept of discrete space and time offers further insight. Quantum mechanics and theories of quantum gravity propose that space-time may not be continuous, but instead composed of discrete units at the Planck scale. This notion parallels the idea of pixels or grid points in a digital simulation, where reality is rendered in finite increments rather than infinite continuity. Reflecting on this calmly highlights the astonishing precision of the cosmos, offering a bridge between physical observation and computational metaphor. Mathematical patterns are also found in the large-scale structure of the universe. Galaxies, cosmic filaments, and voids exhibit fractal-like distributions, self-similarity, and recurring symmetries. Some researchers suggest that such order could be consistent with underlying computational rules. Even if these patterns arise naturally, the observation reminds us of the universe's inherent elegance. Mathematics appears as the silent language shaping everything from subatomic particles to cosmic webs. Quantum phenomena further invite contemplation. The probabilistic nature of quantum mechanics, wave function collapse, and entanglement can be interpreted as computational shortcuts, methods of conserving resources in a complex system. For instance, particles may not exist in a defined state until observed, suggesting a form of selective computation. While physicists typically explain this behavior within natural frameworks, considering the computational analogy fosters serene reflection on the delicate, interwoven principles that govern reality. Another dimension comes from information theory. Some theorists propose that information is the most fundamental constituent of reality, with energy and matter being emergent properties of information processing. If the universe is fundamentally informational, then it is already analogous to a computational system, whether or not it was explicitly designed. Calm reflection on this principle encourages mindfulness. The universe can be appreciated as a harmonious interplay of structure, law, and information, all accessible to observation and understanding. Finally, mathematics and computation in the context of the simulation hypothesis inspire intellectual humility and wonder. We may not yet fully grasp the code of reality, and we may never know the ultimate origin of the universe. Yet the ability of human minds to discern patterns, formulate equations, and uncover hidden structure is remarkable. The search for computational clues becomes not only a scientific endeavor, but a meditative practice, observing patterns, contemplating possibilities, and appreciating the profound coherence that enables life, consciousness, and discovery. In conclusion, the mathematical and computational perspective enriches our understanding of the simulation hypothesis. From the precision of physical laws to error-correcting codes, from algorithmic complexity to quantum phenomena, the universe exhibits characteristics that parallel a computational system. Calmly exploring these ideas fosters awe, reflection, and intellectual curiosity. Whether or not reality is a simulation, mathematics reveals the deep elegance, structure, and beauty of existence, a reminder that the universe, in all its complexity, is a canvas for exploration, contemplation, and wonder. Section 10. Consciousness and the simulated universe, observers as participants. As we journey further into the simulation hypothesis, one of the most captivating areas to explore is consciousness itself. What is the role of awareness in a potentially simulated reality? Could our minds not only perceive, but also influence or co-create aspects of the universe? By calmly examining the relationship between consciousness and the structure of reality, we find a space for wonder, reflection, and deep appreciation of the profound mysteries of the mind. At the heart of this discussion lies the idea that consciousness may be central to the operation of reality. In quantum mechanics, the observer effect demonstrates that the act of observation can influence the state of a particle. While interpretations vary, this suggests that awareness is not a passive phenomenon, but may interact with the unfolding of events at the fundamental level. If reality were a simulation, consciousness could serve as both participant and interpreter, engaging with the rules of the system while shaping the experiences it encounters. Calm reflection on this notion highlights the significance of awareness. Even in a universe governed by algorithms, perception remains deeply meaningful. Another compelling aspect involves subjective experience and the authenticity of consciousness. Even if a simulated universe were programmed by an external intelligence, each conscious mind would experience reality with genuine sensation, emotion, and thought. Joy, curiosity, creativity, and empathy remain authentic, regardless of the underlying substrate. The possibility that our universe is a construct does not diminish the depth or value of lived experience. In fact, it can enhance appreciation for the miracle of consciousness itself. The ability to perceive, reflect, and interact with a richly detailed world. The simulation hypothesis also raises questions about the interconnectedness of minds. In a sophisticated simulation, conscious entities could interact in ways that produce emergent phenomena, unexpected behaviors and relationships arising from the interactions of participants. This mirrors real-world experience, where individual choices ripple through networks of social, ecological, and physical systems. Calm contemplation of this perspective encourages gratitude for the subtle influence of awareness, both on oneself and on the broader web of life, and fosters a sense of connection to other conscious beings. Free will and agency are similarly intriguing. In a simulated universe, constraints may exist, but these do not necessarily negate meaningful choice. Just as a character in a virtual environment may navigate complex rules, we exercise decision-making within the physical and social laws of our universe. Awareness allows us to perceive constraints, reflect upon possibilities, and act intentionally. This duality of structure and freedom mirrors real life, inviting calm appreciation for the delicate balance between determinism and agency. Exploring consciousness also brings attention to the nature of memory and identity. Our thoughts and memories form the continuity of self, shaping how we experience the present and imagine the future. In a simulation, these mental constructs could be part of the system or emergent within it. Either way, they are authentic from the perspective of the experiencer. Reflecting on this encourages mindfulness. The mind is a vessel of perception, creativity, and introspection, capable of deep engagement with the unfolding universe. The role of attention is particularly noteworthy. In a simulated or constructed reality, resources may be allocated efficiently, rendering only what is observed or interacted with, akin to modern computer graphics that focus on the user's viewpoint. This analogy resonates with human consciousness. What we focus on becomes vivid and detailed in our awareness. Calm reflection on attention reminds us that mindfulness and intentional focus are not only psychologically valuable, but could also be fundamentally linked to the richness of experience itself. Consciousness may also serve as a bridge between reality and abstraction. Humans are capable of imagining worlds, exploring hypothetical scenarios, and conceptualizing realities beyond immediate perception. In a simulated universe, this ability could mirror the capacity of higher-level intelligence to explore and model environments. Calmly considering this perspective fosters humility and wonder. Our minds participate in the exploration of possibility, whether by interpreting a programmed system or by navigating the natural laws of the universe. Finally, reflecting on consciousness within the simulation hypothesis encourages ethics and compassion. If each mind, whether simulated or not, experiences life vividly, then understanding and empathy gain profound significance. Our thoughts, choices, and actions have consequences in the network of conscious experience. By cultivating awareness, kindness, and curiosity, we engage fully with the meaningful reality we inhabit, regardless of its underlying structure. In conclusion, consciousness plays a central and profoundly meaningful role in the simulation hypothesis. Awareness is both the medium through which reality is experienced and potentially a participant in shaping that reality. Even if the universe were constructed or computational, the authenticity, depth, and significance of conscious experience remain undeniable. Calm reflection on this relationship invites wonder, mindfulness, and reverence for the extraordinary complexity and beauty of the mind. Our consciousness allows us not only to perceive the universe, but to explore, interpret, and co-create the richness of experience, offering a profound source of awe, curiosity, and quiet contemplation. Section 11. Testing the simulation. How could we ever know? As we reach one of the most intriguing parts of the simulation hypothesis, we enter a quiet space of scientific curiosity. The question of whether there is any way to test if our universe is, in fact, a simulation. While definitive proof remains beyond our grasp, researchers have proposed several thought-provoking methods, some scientific, some philosophical, that may one day offer insight. Exploring them calmly helps us appreciate both the limits and the beauty of human inquiry. One possibility lies in examining the smallest scales of reality, down to the quantum level. If the universe is simulated, it may rely on a form of discrete resolution, similar to pixels in a digital image. At the Planck scale, the smallest meaningful measurements in physics, space and time may be quantized. Scientists have proposed searching for pixelation patterns in the universe by examining the distribution of cosmic rays or studying tiny irregularities in high-energy particle behavior. If space behaves as though constructed from a grid, this could hint at an underlying computational structure. Reflecting on this idea invites a sense of wonder. Even the fabric of reality might carry faint traces of its origins. Another approach involves the speed of light, which could represent a maximum processing speed of the system. In a simulated environment, there might be limits to how fast information can be exchanged. The speed of light appears to serve this function in our universe, acting as the cosmic speed limit for all interactions. While this may be a natural physical property, some theorists argue that such limits resemble constraints in computational systems. Contemplating this possibility offers a serene appreciation for the elegance of natural laws, whether they arise from physics or programming. Quantum randomness provides yet another path. When particles behave unpredictably, such behavior could represent either genuine uncertainty or an algorithm generating probabilistic outcomes. Some scientists have joked that quantum randomness looks suspiciously like a computer using shortcuts. But even if randomness is fundamental and not simulated, considering this parallel encourages us to calmly reflect on the uncanny parallels between quantum behavior and computational processes. More theoretical proposals involve searching for mathematical inconsistencies, tiny glitches or irregularities in the cosmic background radiation, gravitational fields, or particle interactions. Just as digital simulations sometimes produce artifacts when pushed to their limits, a simulated universe might reveal subtle imperfections when examined at extreme scales. So far, no conclusive evidence exists, but the act of searching deepens our understanding of physics. Whether or not we find anomalies, the pursuit itself expands human knowledge. One of the most famous approaches comes from philosopher Nick Bostrom's argument that if advanced civilizations can create realistic simulations of universes, and they produce many of them, statistically, we are more likely to be in one of the simulations rather than the one base reality. Testing this logically is difficult, but it sparks calm contemplation. The search for truth may require investigating not just physical laws, but philosophical reasoning about existence and probability. Another method involves exploring cosmology for signs of resource optimization. In a computational model, high detail rendering may occur only where necessary, similar to how video games focus processing power on the player's field of view. Some theorists propose that the universe might show evidence of lazy loading, rendering details only when observed. Quantum mechanics partially reflects this idea. Entities often remain in probabilistic states until measured. This interpretation remains speculative, but contemplating the analogy reveals the deep and fascinating relationships between observation, information, and physical behavior. Researchers have also suggested looking for limits on computational complexity in physics. For example, if certain phenomena are too computationally expensive, a simulated universe might restrict them or simplify their outcomes. Physical systems often balance complexity with surprising efficiency, behaving elegantly rather than chaotically. Whether this reflects natural optimization or intelligent design remains unknowable. But the simplicity to complexity harmony inspires calm reflection on the beauty of universal laws. One potential signature is the idea of synthetic constants. If the universe were programmed, certain fundamental constants, such as the cosmological constant, gravitational constant, or Planck constant, might appear arbitrary or finely tuned. Indeed, many constants in nature seem enormously precise, enabling stars, galaxies, and life to exist. Are these values natural necessities, results of cosmic evolution, or parameters set in a simulation? We may never know, but contemplating these mysteries deepens appreciation for the harmony that permeates existence. Finally, some suggest that if we live in a simulation, there may be ways to communicate with or detect the simulator, not by breaking the laws of physics, but by recognizing the constraints embedded within them. Messages encoded in cosmic patterns, subtle asymmetries, or mathematical structures could theoretically serve as signatures from a higher intelligence. While no such evidence has been found, the idea encourages quiet humility. The universe may contain layers of meaning still far beyond our recognition. In the end, testing the simulation hypothesis is as much a philosophical challenge as a scientific one. There may be no definitive experiment capable of revealing the truth, especially if the simulation is sufficiently advanced. And yet, the search itself brings value. It pushes us to examine the deepest structures of reality, to confront the limits of perception, and to marvel at the immense coherence of the cosmos. Even if we never find answers, the pursuit fosters curiosity, wonder, and intellectual peace. Whether simulated or natural, the universe invites us to explore, to observe, and to reflect. And in this calm inquiry, we find meaning, not in certainty, but in the beauty of the quest itself. Section 12. Philosophical Implications. Living in a Simulation. As we approach the final stages of exploring the simulation hypothesis, it becomes essential to reflect on the philosophical implications. What would it mean for our lives, our ethics, and our understanding of reality if we were to discover that the universe is a simulation? While such a revelation remains speculative, calmly contemplating these possibilities allows us to explore the profound meaning, value, and purpose inherent in conscious experience. One of the first questions to consider is identity and selfhood. If reality is constructed, does this diminish the authenticity of our experiences? Philosophers and thinkers argue that it does not. The subjective reality of consciousness, the richness of emotion, thought, perception, and memory, remains genuine, whether or not it is simulated. Our joys, sorrows, dreams, and aspirations retain their significance. Calm reflection on this idea highlights that meaning emerges not solely from the external substrate, but from awareness itself. Life, thought, and relationships are inherently valuable, regardless of whether the universe is a construct. Ethics and morality also take on new dimensions. Living in a simulated reality could prompt questions about responsibility to ourselves, to others, and even to the creators of the simulation. Does knowing that our universe is potentially artificial change how we act? Many argue that it should not. Ethical behavior retains importance because consciousness is still real, and actions affect experiences within the simulated framework. Calmly reflecting on this encourages mindfulness, empathy, and intentional living. The authenticity of our choices matters, independent of the underlying nature of reality. The concept of purpose and meaning may also shift. Some might fear that a simulated universe would render life arbitrary or insignificant. Yet, discovering we live in a simulation could instead inspire awe and creativity. If a civilization or intelligence created a universe capable of conscious experience, it suggests that intelligence values exploration, creativity, and the richness of life. From this perspective, our experiences are part of a grand tapestry, and meaning arises from participation, discovery, and awareness. Calm contemplation transforms the idea from existential dread into profound appreciation. The simulation hypothesis also invites reflection on free will and determinism. In a simulated universe, Certain constraints or rules may exist, shaping outcomes and interactions. However, these constraints do not necessarily negate agency. Just as characters in a sophisticated simulation navigate complex environments with authentic responses, conscious beings exercise choice within boundaries. A calm perspective encourages acceptance of these limits while celebrating the richness of decision-making, reflection, and creativity that defines the human experience. Knowledge and curiosity take on a renewed significance in a simulated reality. If we are living in a system governed by rules or algorithms, the act of discovering those rules becomes a noble pursuit. Scientific exploration, philosophical inquiry, and artistic creation are ways of engaging with the universe, probing its structure, and appreciating its elegance. Whether or not the cosmos is simulated, the journey of discovery enriches life, cultivates awe, and fosters a serene sense of connection to the vastness of existence. The simulation hypothesis also encourages humility. Recognizing that reality may be constructed reminds us of the limits of human understanding. There may be layers of complexity, intelligence, or design that exceed our comprehension. Calm reflection on this possibility fosters patience, curiosity, and respect for the unknown. Rather than inducing fear, it inspires quiet wonder and reverence for the intricate balance of the universe and the richness of conscious experience. Additionally, considering life in a simulation highlights interconnectedness. If reality is constructed, it is remarkable that conscious beings can still experience joy, love, learning, and collaboration. Relationships, cooperation, and shared experience gain profound significance, demonstrating that even within constraints, richness and beauty emerge. Calm contemplation of these connections encourages gratitude, empathy, and appreciation for the network of conscious life in which we participate. Spiritual and existential reflections are also relevant. Throughout history, humans have contemplated the possibility that life exists within higher orders or dimensions, whether through theology, philosophy, or mysticism. The simulation hypothesis resonates with these traditions, framing reality as layered, structured, and possibly guided by intelligence. Reflecting on this calmly, one can see a bridge between ancient philosophical ideas and modern scientific speculation, emphasizing the enduring human fascination with the nature of existence and consciousness. Finally, the philosophical exploration of living in a simulation encourages active engagement with life. Whether the universe is simulated or not, awareness, choice, curiosity, and creativity remain central to a fulfilling existence. We can approach each moment with mindfulness, explore the cosmos with wonder, and interact with other conscious beings with empathy. In this sense, the hypothesis becomes a tool for reflection, guiding us to live deliberately, to appreciate the complexity of existence, and to cultivate serenity in the face of uncertainty. In conclusion, the philosophical implications of the simulation hypothesis invite calm contemplation rather than fear. Identity, ethics, purpose, free will, and interconnectedness retain their significance even in a potentially constructed reality. The idea encourages humility, curiosity, and appreciation for the richness of consciousness, while reminding us that meaning arises from awareness, engagement, and reflection. Whether simulated or not, life remains profoundly beautiful, intricate, and worthy of reverent attention. Section 13. Reflections on the Simulation Hypothesis. As we reach the final section of our exploration of the simulation hypothesis, it is time to reflect calmly on the journey we have taken through philosophy, physics, mathematics, and consciousness. Throughout this journey, we have considered questions that are at once deeply speculative and profoundly beautiful. What if our reality is not the ultimate layer, but a carefully constructed system? What if consciousness itself is both observer and participant in a complex cosmic algorithm? Even without definitive answers, the contemplation of these possibilities offers insight, serenity, and wonder. One of the most striking insights is that the universe, whether simulated or not, remains profoundly elegant and ordered. From the precision of physical constants to the emergence of complexity in stars, planets, and life, the cosmos demonstrates patterns and structures that inspire awe. Whether these patterns arise from natural law or an intelligent framework, their existence reminds us of the extraordinary coherence of reality. Calm reflection allows us to appreciate the harmony and balance that pervade every scale, from quantum particles to the vast cosmic web. The exploration of consciousness has been equally revealing. Our awareness is not merely passive. It interacts with reality, shapes experience, and brings meaning to life. Even if we were to inhabit a simulated universe, the subjective richness of perception remains genuine. The colors we see, the emotions we feel, the connections we form, these experiences are authentic in the mind that perceives them. One of the most interesting and thought-provoking sentences from this script captures this beautifully. Even if the universe is a simulation, the depth, authenticity, and significance of conscious experience remain undeniable, turning every thought, emotion, and act into a profound engagement with reality itself. This idea anchors the simulation hypothesis in a calm and reassuring perspective. The value of life and consciousness is intrinsic, not dependent on the underlying nature of the universe. Awareness transforms every interaction, every observation, and every moment into an experience of richness and significance. Philosophical reflections remind us that ethics, purpose, and meaning remain central, even in a potentially simulated reality. Our choices, relationships, and actions retain their weight. Compassion, curiosity, creativity, and mindfulness are as important as ever. Contemplating the universe as a constructed system may deepen our reverence for life, inspiring us to live intentionally, appreciate subtle patterns, and engage fully with the world we perceive. Calm reflection shows that meaning arises not from the ultimate substrate of reality, but from how consciousness interacts with the unfolding of experience. The scientific perspective, examining mathematical structures, quantum phenomena, and cosmic patterns, further enhances our understanding. The universe exhibits astonishing consistency, harmony, and elegance. Whether it is the fine-tuning of physical constants, emergent complexity, or the mathematical precision of natural laws, these features demonstrate that reality, simulated or not, operates according to principles that are comprehensible, beautiful, and inspiring. Observing these patterns encourages serenity, curiosity, and reverence for the cosmos. Finally, the contemplation of the simulation hypothesis highlights humility and wonder. There may be layers of reality, principles, or intelligences beyond human comprehension. Acknowledging this does not induce fear. Rather, it inspires awe, gratitude, and mindfulness. The universe invites us to explore, reflect, and engage fully, embracing mystery while appreciating the beauty and coherence of what is observable. In this calm awareness, we find the most meaningful insights. The universe, in all its complexity and subtlety, offers a space for curiosity, wonder, and profound reflection. In conclusion, the simulation hypothesis serves not only as a speculative idea about the nature of reality, but also as a lens for appreciating consciousness, ethics, and the elegance of the cosmos. Whether we live in a simulation or an ultimate reality, the journey of observation, reflection, and engagement imbues existence with richness and meaning. The layers of science, philosophy, mathematics, and consciousness converge to offer a singular insight. Life, thought, and experience remain deeply significant, and the universe, seen through calm contemplation, remains endlessly beautiful. As we end this journey, we are reminded that the simulation hypothesis is less about proving or disproving reality, and more about inviting us to explore the profound mystery of existence. Every moment we observe, think, or connect with the world is part of this intricate dance between awareness and reality, whether simulated or natural. By embracing curiosity, mindfulness, and wonder, we engage fully with the cosmos, experiencing the elegance, depth, and mystery that make life, thought, and consciousness remarkable.